This is Mr. Martin. These are the video notes for Geometry Honors, Section 9.2, Introduction to Circles. So a lot of information in this video. Um, so let's take a look at our circle here. Definition of a circle is the set of all points a given distance from a given point. Okay, so we've got our center, and then we're going to find all the points that are, say, 3 centimeters from that point, and all of those points that are 3 centimeters from the center are going to be the circle. Okay, radius, distance from center to the circle. That's our symbol for circle, and I'll use that almost all the time. And then we've got what's called a central angle. So if I draw another radius, then I form an angle here. Okay, so this is an angle formed by 2 radii. That's the plural of radius. Alright, and then we've got a diameter. Segment that joins 2 points on the circle and passes through the center. Okay? Now this differs from a chord, because a chord is a segment that joins 2 points on the circle, but it does not have to go through the center. So this is a segment that joins any 2 points on the circle. Right, so if we go back up here, and I've got a point over here, and a point over here, and I connect those, we can call this AB. AB would be a chord. Now a diameter is a chord, it's just a special chord that happens to go through the center. Alright, so let's draw another circle here. And let's put a couple of points on the circle. I'm going to call this circle O. We're going to call this A, B, and C. So an arc of a circle is 2 points on the circle and all the points between them. So in my picture here, I would have, for example, arc AB. Notice the symbol I put above. That's the arc symbol. We say arc AB. So this is an arc, and we can see that it's less than half the circle. It's called a minor arc. If we look at an arc that's more than half the circle, we're going to have to use 3 letters. So I could refer to arc ABC, and this is more than 180 degrees. It's more than half the circle, and we would call that a major arc. Now, when we talk about the measure of the arc, what we want to do is we want to look at the central angle that corresponds to that. So the measure of an arc, it's the same as the measure of its corresponding central angle. Okay, so if this angle here is 50 degrees, then the measure of this arc would also be 50 degrees. Okay, so measure of an arc and length of an arc, those are two very similar concepts, But when we talk about the length of an arc, if I'm standing over here at A and I want to walk over to B, how far would that be? So the length of an arc is actually a fraction of the circumference. Alright, so the length of arc AB would be 53/60ths, that's what fraction of the circle it is, times the circumference, which is pi times diameter, or 2 pi times radius. We'll look at that in a minute. Alright, so area of a circle. Area of circle is pi r squared. Okay, don't forget units. It's going to be in square units. And we're going to talk about the sector of a circle. So again, I'm going to have a circle here, and this shaded area here is called a sector of a circle. Okay, this is a fraction of the circle's area. Okay, so again, if I knew that this arc was 50 degrees and I wanted to find the area of the sector, it would just be 53/60ths of the area. Alright, so this actually is going to go down over here. Area of a sector is a fraction of the circle's area. And then this shaded area here, this is a sector of a circle. So really, it's like a pie-shaped piece of the circle. Okay? Alright, so let's talk about an inscribed angle. So we've got another circle here. Here's my center. I'm going to draw a chord, and then I'm going to draw another chord that meets at this same point over here. So here I've got point A, point B, point C. So with these 3 points, I have an angle with its vertex on the circle. So this is angle formed by 2 chords. Its vertex is on the circle. Okay, so notice that this is not a central angle because its vertex is not at the center. So if I was going to draw in this radius here and this radius here, call that O, then angle AOC would be a central angle. Angle ABC is an inscribed angle. So you see, remember, an angle is made up of 2 rays, so really this is a ray that goes on forever over here. This is a ray that goes on forever over here. This angle cuts off a piece of the circle right over here. It cuts off this arc. We say that it intercepts the arc. So when something intersects at more than one spot, we say that it intercepts. Okay, so an intercepted arc is a part of the circle cut off by an inscribed or central angle. It can also be formed by some other stuff, but for now this will be good. And there's a special relationship between the inscribed angle and the intercepted arc. Okay, so let's take a step back here. The measure of the central angle is equal to the measure of the intercepted arc, but the measure of the inscribed angle is equal to half the intercepted arc. Alright, So if this angle over here was 25 degrees, this angle is half the arc, so this arc would be 50 degrees. And again, since the arc and the central angle are the same, this central angle would also be 50 degrees. So let's take a look at some inscribed angles that intercept the same arc. So here's my arc AB, and I'm going to draw an inscribed angle here. So if this angle is x, we know that this arc has to be 2x, because it's got to be twice as much. The inscribed angle is half the intercepted arc. So let's draw another inscribed angle here. Let's call this point C. Let's call this point D. So we know that angle ACB intercepts arc AB. Alright, and we know that the inscribed angle is half the intercepted arc. Angle ADB intercepts, so ADB, it also intercepts arc AB. So if these two inscribed angles intercept the same arc, they have to be half of the same arc measure. Okay, so that means that they're going to have to be equal, so this is going to be x. So inscribed angles that intercept the same arc, angles will be congruent. This is a really important concept because we're going to see this all the time, and you can see how the picture could get a little bit complicated right away. So here's another chord, here's another chord, so I'm forming another inscribed angle over here. So I've got this angle here, which intercepts arc AB. I've got this angle here, which also intercepts arc AB. And I've got this angle here, which also intercepts arc AB. So all three of these angles have to be half of 2x, so they're all going to be x. So any angle that I could draw in here would have to be half of that arc. Alright, so as always, if you have any questions, make sure that you ask. And there are a bunch of problems to do in this set. So again, make sure you ask questions, write them down so you don't forget, and we'll see you next time.